This video will discuss similar right triangles. So what you see is a depiction of a larger right triangle, which has that little right angle symbol that is cut by the altitude, and it creates two additional triangles. So when that altitude actually bisects that right angle, then what ends up, well, not bisects, but it cuts it, it creates a perpendicular bisector. So what you want to do is you want to go ahead and draw in your right angle notations. That's going to be important because that will help you locate your hypotenuse. So as you can see, I've color-coded it to show you which triangles have the different components. So you might want to refer back to this afterwards if you're still having problems once we go through these examples. So I have 3 examples for you, and we're going to try to find the value of x. Again, we have 3 triangles. I label them triangle 1, triangle 2, and then the big one is triangle 3. So this is the big one. Now, what you want to look for initially, or at least this is my strategy, is each side of the big one. And you want to see whether or not you have information. If you have 2 out of the 3 sides, then that means that you could possibly, you will be using that larger triangle. So I called it triangle 3. So for triangle 3, I said that I want to use my hypotenuse. And again, this is my triangle 3. My hypotenuse is always directly across from my right angle notation. So that's over here. So I know that my hypotenuse in this case is going to be x. And then I said I wanted to use the leg that goes with my larger triangle. So my larger triangle has the leg 21. And now I'm going to go to triangle 2. Why wouldn't I go to triangle 1? Well, if I go to triangle 1 and I highlight this, I see that I don't have enough information. I don't have anything actually. So I could find something. I could go ahead if I wanted to and find this side, and that's going to simply be x minus 7. But even still, I don't have enough information. If I'm looking at my triangles, I need information for at least 2 sides. So if I'm looking at triangle 1, I only have information for 1 side. So I couldn't use that even if I wanted to. But just know, if you ever see x as your longer hypotenuse, let me get rid of that. Then what I would need to do is just go ahead and use my segment addition, postulate backwards. So x minus 7, that's where I got this from. So had that been like 16, you would have said 16 minus 7, then you would have put a 9 there. So that's how that works. Now back to the regularly scheduled program. So for triangle 2, I see that I have information for 2 sides. So because I have information for 2 sides, I just have to make sure that I place it correctly in the numerator and denominator. So what you want to do is you want to find what they share and then place those items diagonally. So I've already used this for the leg, and this is now my hypotenuse for triangle 2. How do I know? Because this is my right angle, and directly across from it is going to be my hypotenuse. So 21 would have to be diagonally. You want them to look exactly the same, whatever they share. So if they share a side or a hypotenuse, we want it, if it's like a variable x and x, or if it's a number, make sure that they're diagonally. So by default, the only thing that's left for triangle 2 is 7. So that's what we're going to put here. And now we can cross multiply. We have 7 times x, which is 7x. And that's going to be equal to 21 times 21, which is 441. And then you want to divide both sides by 7 so that x is by itself. And x is simply 63. So again, the first thing you want to look for when you start the process is look at all of the sides of the bigger triangle and see if you have at least 2 items. If you do, you will be using a hypotenuse. If you do not, you will not be using a hypotenuse. So this is a case, an example of what I'm saying. So if I look here for the big triangle, I have information. If I look here, I don't. I look here, I don't. So therefore, I only have one hypotenuse, and that's for the larger triangle. I don't have a hypotenuse for triangle 1 or 2, so I can't use hypotenuse. So I'm going to use what's left over, long leg and short leg. So for triangle 1, and I like to also display which triangles I'm using, so that'll help me keep track or be organized of where the data is supposed to go. So for triangle 1, I have 2 items here. I can decide which one I want on top. I just have to be consistent. I said that I wanted the longer leg. So this is the longer leg, 12. So I'm going to write 12. And then I want the shorter leg, which is going to be X. If I look at triangle 2, what does it have in common with triangle 1? What side did they share? Well, they both have the X. So I want to make sure that X is diagonal. So that happens to be my longer leg for triangle 2. My shorter leg is 4. If I see diagonally that I have the same variable or same number, I'm on the right track. So X times X is X squared. And then 12 times 4 is 48. So I don't want X squared, I want X. The inverse of X squared is to take the square root. Once I do that, I have X is equal to, and then I can further simplify this. This is going to be 16 times 3, or you could say 6 times 8, but you want to keep going to the simplest radical form. And so this would actually be 4 radical 3. That's how I want you to leave your answer, as a radical. And then our last example, my first strategy is to look around my bigger triangle to see if I have information for 2 sides. I do not. I only have the information for the hypotenuse of the bigger triangle, so I can't use the hypotenuse. I do have 2 legs, and then I want to see what they share. So it doesn't matter. A few minutes ago, I did long leg over short leg. Now I'm doing short leg over long. It doesn't matter. You just have to be consistent. Whatever you put on top stays on top, whatever you put on bottom. All right, so for triangle 1, this is why I label. I see that my shorter leg is 10. So I'm going to go ahead and put 10 in the numerator. And then my longer leg is 2 radical 5. Again, it doesn't really matter short and long. You can say long, leg 1, leg 2. It doesn't matter. What does matter is when I go to triangle 2, I see that they share a leg. If they share a leg or any part of that triangle, it has to be diagonally set diagonally apart from the other one. So if I have already used 2 radical 5, the only thing that's left for triangle 2 is X. So that's what's going to go on the bottom. And now I can start the process of cross multiplying. 10 times X is 10X. And then if I'm multiplying a radical times itself, so what I want to do is focus on the number that's on the outside. So 2 times 2 is 4. Times, and then radical 5 times radical 5 is going to be the radicand. Whatever is under that radical, that will always be your answer. So 10x is equal to 4 times 5, which is 20. And then I'm going to divide both sides by 10. And therefore, x is simply 2. That is how you simplify. That's how you actually do these problems when you're trying to figure out similar right triangles. Okay, we're done with the video. Hope that was helpful. Please like and subscribe. Have an awesome day.